All right, so in this video, we are going to do a review of chapter 6 quadratic equations. I'm just going to cover all the concepts in the chapters, but I'm not going to do any kind of word problems or any complex problems. I'm just going to cover all the basic concepts. I'm going to do it quite quick, so hopefully we can get through it in less than 30 minutes. Don't think this is going to be a long one. So let's get started. So the first thing I want to mention is that for quadratic equations, we have three forms. We have standard, we have factored, and we have vertex form. Now, we've definitely done a lot of factoring in the chapter 5 review. So if you don't know how to factor, make sure you watch that video first before this, because I won't be explaining factoring. I'll just be doing the questions really quick here. But these three forms, factored form tells us our x-intercepts, vertex form tells us our vertex, and standard form we can get our y-intercept. And we can use these then to sketch the graph of any kind of quadratic function. So that's the main purpose of this chapter right here. It's to learn how to sketch and kind of know the features of quadratic equations. So let's get started. The first thing we're going to learn is to go from standard form to vertex form. We already did standard to factored form in chapter 5. That was factoring. We're not going to cover that in this chapter. We're going to go straight from standard to vertex. And the method is going to be called completing the square. Now, I know there's a couple of ways to do this. You can also do this with partial factoring, but I find completing the square a lot easier. So I'm going to start with completing the square. So let's say I have an equation x squared y equals x squared plus 6x minus 1, and I want to find just the vertex of this equation. I don't want to sketch this or anything. I just want to find the vertex. Well, I can start by completing the square. So for completing the square, you want to bracket the first two terms. And if there's any number here, you want to factor it out. In this case, there's no number, so there's nothing to factor out. The next thing you want to do is find something called your magic number. And you take this number here before the x, you always divide it by 2 and you square it. So 6 divided by 2 is 3, and 3 squared is 9. So this is my magic number 9. I want to add and subtract the magic number inside the bracket. So technically the equation has not changed at all. So I just add and subtract it over here. And then you want to bring the negative number outside and multiply it by whatever's in front. Since there's just a positive 1 in front here, it's just going to stay the same. And then the last step is we want to perfect square this bracket. That's what we learned in chapter 5. So the perfect square here is x plus 3 squared. And we want to combine these two like terms, which is going to be negative 10. So this is vertex form right here, similar to transformation form. I can tell that this is a positive equation because the a value is positive. That means my graph has a minimum. If you're positive, it's a minimum. If you're negative, it's a maximum. The x value of the minimum is negative 3. And the y value is this over here, which is negative 10. So if I did a quick sketch of this, and I won't sketch too many right now because sketching is going to come later on. Negative 3, negative 10 is somewhere here. And this graph opens up. It has a minimum, but we don't actually know the x and y intercepts. Well, technically, we know the x-intercept. If you look at the question, the standard form, we know the x-intercept is negative 1. It's just a c value. So luckily, my sketch was accurate. And I can label this negative 3, negative 10. And I know I have two x-intercepts as well that we can find with factoring and some kind of other methods as well. That I'll explain in a bit. Okay, so we can have slightly harder questions. For example, we can have y equals negative x squared plus 80x minus 100. So same idea here. I want to bracket my first two terms. I want to factor out the number over here, which was not possible because it was just a 1 in the last question. So now my second step is to actually factor out the negative. I'm left with x squared minus 80x minus 100. I want to find my magic number. So I'm going to take this value, negative 80 divided by 2, and square it. That's negative 40 squared, which is 1,600. I'm going to add and subtract my magic number inside the bracket. And the whole point of the magic number is it always creates a perfect square in the bracket. That's why we do that, dividing by 2 and squaring. I want to bring the negative number outside the bracket next. Remember, you have to multiply by what's in front. Negative 1600 times negative 1 is positive 1600. And then last step over here is I want to perfect square this. So that's going to be x minus 40 squared plus 1,500. This is a negative quadratic equation. So I know that it opens down, which means that I have a maximum. The x value is the opposite of this, which is positive 40, and then that's the y value, which is 1,500. Again, if you sketch this out, positive 40, positive 1,500, somewhere over here. So this just looks something like this. And then that value we know is just negative 100. So like I said, the whole point of completing the square is to find the vertex. And I'm not going to sketch anymore right now. I'm just going to do a couple of quick harder practice questions of this. Because like I said, we'll get into sketching a bit later. Let's do this one next. It's not too difficult. You should be able to do it if you follow the last one. Bracket my first two terms. Factor out the 3. Find my magic number. 30 divided by 2 is 15. 15 squared is 225. Bring the negative out and multiply with the number in the front. And then perfect square the bracket. That's just x plus 15 squared. And that's negative 625. My vertex is positive, so it's a min. X value is negative 15. Y value is negative 625. Okay, we can have harder questions in terms of factoring as well. You can have questions which will probably involve fractions. So let me show you an equation with fractions. You can have, for example, y equals negative 2x squared minus 3x plus 7. So I'm going to bracket my first two terms, but what you notice is you can't factor out a negative 2 out of a negative 3, but you still have to factor this negative 2 out and create a fraction or a decimal. I stick with fractions because they are way more accurate. So if I factor out negative 2, negative 3 divided by negative 2 is positive 3 over 2. I'll find my magic number next. That's 3 over 2 squared. That's just 3 over 4. Oops, 3 over 2 divided by 2 squared. Because this number divided by 2 squared, which is 3 over 4 squared, which is 9 over 16. So I have negative 2x squared plus 3 over 2x plus 9 over 16 minus 9 over 16 plus 7. And I want to bring the negative number out. And when I do that, I'm going to multiply with negative 2. So negative 2 times negative 9 over 16 is just positive 9 over 8 plus 7. I want to perfect square this bracket over here. So that's just x plus 3 over 4 squared. Then I want to add these two. I'll just do that in my calculator. But if you want to do it manually, you would just use a common denominator. It's just 65 over 8. And then I know this is a max. The x value is negative 3 over 4, and the y value is 65 over 8. Okay, so that covers the first main concept in this chapter, completing the square, finding the vertex, and then we saw sketches with just the vertex. But we're going to get into finding the x-intercepts next. I'm going to start with a few questions that have been factored for us already. So let's say we have x plus 5, x plus 2 equals to 0, and we want to find the x-intercepts. This is already fully factored. So when it's factored, you can actually split your equation into x plus 5 equals to 0 and x plus 2 equals to 0. And if I solve this, I just move the 5 to the other side, so x equals negative 5. Here I move the 2 to the other side, so x equals negative 2. Let's take a look at another one, x minus 3, x plus 4 equals to 0. By the way, these are x-intercepts right there. You don't want to do all those steps. You want to be able to tell your solutions instantly. So here x equals to 3 and here x equals negative 4. Really important to be able to do this instantly without wasting time on the steps. Let's do another one, x times x plus 9 equals to 0. So whenever you have a common factor of x, the x-intercept is always 0. And this one is just negative 9. How about if we get complex factors? So for example, 2x plus 3, x minus 5 equals 0. This one we know is just x equals to 5, but let's solve this one over here. So 2x plus 3 equals to 0, 2x equals negative 3, then divide by 2, so x equals negative 3 over 2. So now our solutions become fractions when we have complex factors. Let's try another one, but now I'm going to show you how to do it really quick. Again, I have two complex factors over here. What you want to do is basically in your mind, you want to hide that first number and just do your solution. So here the solution is positive 1, then just divide by that number over there. Same thing for this. Here my solution is negative 4, and then just divide by the number over here. Okay, next thing is they might give you a standard form for an equation. So x squared plus 8x plus 12 equals to 0. Then we're going to factor this with our man method. That's what I taught in chapter 5. I'm going to do it quick because at this point you should know how to do it. My numbers are 6 and 2, x plus 6, x plus 2 equals to 0. So x equals negative 6, x equals to negative 2 are the x-intercepts. Let's go to a more difficult one. Let's go to 3x squared plus 28x plus 9 equals to 0. This is a complex trinomial, so m is 27, a is 28, and my two numbers are 27 and 1. I'm going to do factoring by grouping now. So 3x squared plus 27x plus x plus 9 equals 0. 3x, x plus 9 plus 1, x plus 9 equals 0. Then common factor out the x plus 9. I'm left with 3x plus 1 equals 0. My two solutions are negative 9 and negative 1 over 3. Let's do this one next. 16b squared minus 1 equals to 0. I just want to do a difference of squares example really quick in case you forgot it. But this is 4b plus 1 times 4b minus 1. It's difference of squares. Should know how to do it from chapter number 5. Here my solution is negative 1 over 4, and here my solution is positive 1 over 4. That's mainly what this chapter is about. Now, sometimes you may get some kind of equations that have terms on both sides of the equations, but the process is pretty much the same. So for example, you can have 2m squared equals negative 7m minus 6. So when I want to factor this over here, what I want to do is I want to move everything to one side. I want to make sure my squared term is positive. So I'm going to move these two to this side and change the signs. So I have 2m squared plus 7m plus 6 equals 0. Now I can factor it using man. So what multiplies to 12 and adds to 7? It's 4 and 3. So I'll do grouping now. Common factor here is 2m. Common factor here is 3. Now I'm left with m plus 2 times 2m plus 3 equals 0. Here m equals -2, and here m equals -3 over 2. Okay, so you can have all the kinds of things that I explained in chapter number 5. Every kind of factoring problem, you can have it in the same chapter. Make sure you know your factoring really well from chapter number 5 before attempting this one. Okay, the next concept we are going to learn is the quadratic equation. And I'm going to explain to you the reason why we're going to learn the quadratic equation. Oh no, actually, before quadratic equation, we're going to do a bit of sketching first. So let's say, for example, we have an equation y equals x squared plus 5x plus 6. And you want to do an accurate sketch of this. Okay, no table of values, just using the methods we learned. So when we're doing this, the first thing we want to do is we want to factor this equation. So what multiplies to 6 and adds to 5, it's just 2 and 3. So we have y equals to x plus 2 times x plus 3, which means our x-intercepts are x equals -2 and x equals -3. So we can sketch this out now. -2, -3, and we know this is a positive graph, so it's going to open up. We also know that the y-intercept from standard form is 6. Let's sketch it out. Doesn't have to be super accurate to sketch. As long as the points are labeled clearly, it's good enough. So that's 6, that's -2, that's -3. Then we can find the vertex of this graph as well by doing the midpoint method. But again, I'll show that a bit later. Just want to show you a bit of sketches with x-intercepts and obviously the y-intercept from standard form. So now we've seen sketches from the vertex, we've seen sketches from the x-intercepts. We're going to do sketches for both. And I'll actually start with this one over here. So if I want to find this vertex, instead of wasting a ton of time turning this from standard form into vertex form, I'll do a different method to find the vertex, which is the midpoint method. So for your vertex, you can do the midpoint of your x-intercepts, which is just adding the two values and dividing by 2. Which in this case is just -2.5. And then you can sub this value back into the original equation to find your y value. So I'll do that in my calculator. And I get -1/4, basically -0.25 if you want to write that as a decimal, because it's not good to have a decimal and a fraction. So -2.5 and -0.25 is the vertex. So pretty easy there to figure out everything. That's an accurate sketch of that. Let's do another example really quick. Let's try y equals, make the examples as different as possible to -x² minus 5x. So I'm going to start by factoring. I have a common factor of -x here, and I'm left with x plus 5. That means my x-intercepts are 0 and -5. I can start my sketch for this. I know my x-intercept and my y-intercept, there's no c value, are both 0. One of them is here, and then -5 is here. I know this graph opens upwards because it's a negative quadratic equation, so it looks something like this. And I know for the x value of my vertex, it's the midpoint of these two. So -5 plus 0 divided by 2 is just negative 2.5. And if I sub in a negative 2.5 into the original equation, I will get 6.25 as the y value. And let's do one last one really quick. Let's do y equals 16 minus x squared. So this one can be factored using difference of squares. It's 4 plus x times 4 minus x, which means my zeros are negative 4 and positive 4. And sketch it out. It's again a negative equation because it's negative x squared. So negative 4, positive 4, vertex will be directly in the middle, which is going to be the same as the y-intercept. That's what happens when you do difference of squares. Your vertex is always the same as the y-intercept. Negative 4, positive 4. I don't even need to do the calculation. I know the midpoint is right there of those two, and the y value is going to be 16 because that's the c value in the equation. And let's try actually one last one. I know I said that one was going to be the last one, but I actually have a couple of good examples. I'm going to do a complex trinomial next. So I'm going to multiply to 14, add to 15, and my two numbers are 14 and 1. I'm going to rewrite this now, 2x squared plus 14x plus x plus 7, and now I'll factor this by grouping. So 2x, x plus 7 plus 1, x plus 7, x plus 7 times 2x plus 1. So here x equals to negative 7, and here x equals negative 1 over 2. Those are my x-intercepts. I can sketch my graph over here. So negative 7, negative 1 over 2, and then the y-intercept is positive 7. I'll label that a bit later. Let me do the sketch first. Oops. Not the best graph over there, slightly messed up, but you get the idea. Negative 1 over 2, negative 7, and then the y-intercept is positive 7 from standard form. Find the vertex, so I'll do the midpoint of these two. So negative 7 plus negative half divided by 2 is just negative 3.75, and then the y value, I'm going to sub in negative 3.75 back into the original equation over there. And I get negative 21.125. And I know I said this one was the last one, but I found another good one. This one's definitely going to be the last one in terms of this concept over here. And this over here may look like a complex trinomial, but it's actually a perfect square. So it's going to be 4x minus 3 squared. And then I only have one x-intercept in this question of 3 over 4. So when you have a perfect square, things get a lot easier. And I'll show you why on the graph. I have one x-intercept here, which is 3 over 4. And I know this is a positive equation, so it's going to open up. It's going to look something like that. Y-intercept over here is positive 9. And this value is 3 over 4. So as you can tell, if you have a perfect square, your vertex is the same as your x-intercept, which means there's no more extra calculations. That's the whole graph. That's the whole problem right there. Perfect square problems are slightly quicker. Okay, the next thing that shows up in this chapter is finding the equations in standard form of equations, quadratic equations. So they'll give you a graph, they'll tell you to find the equation in standard form. And these graphs can differ. So let's start with this one over here, where I have a graph that looks like this. That x-intercept is 0, 0. This one is 6. And then there's a point over here, 5, 5. We need to find this equation in standard form. So in order to do this, we want to first come up with our equation, and we have the x-intercepts. So we know we have to start with factored form. And this is again something that I taught in chapter number 4. So make sure if you don't know what's going on here, I'm going to do it pretty quick. Go back to chapter 4 and you learn it from there. But it's the same process over here. So we're going to replace the two x-intercepts over here, r and s, with the two x-intercepts. So the first x-intercept is 0. So it's just r is just 0. So I just have an x here. The second intercept is 6. So I have x minus 6. And I want to sub in the point to figure out my a value. So I'm going to replace x with 5 and also y with 5. They're both 5s in this one. And I want to solve this. Divide by -5. So a just equals to -1. Now I'm going to rewrite my equation. Y equals to negative. I'm going to use this one over here. So y equals to negative x minus 6. Then if I want to turn this into standard form, I just want to expand this. So that's just going to be negative x squared plus 6x. And that is my final equation in standard form. Let's try another one. So I'm going to squeeze it on this same page. We have another graph that is let me find a good one. All of these are pretty simple. They're all the same. And technically, you could get one in vertex form. I'm just going to do this one over here. -4, +5. Vertex over here is 1 and -6. Now this one, you've been given both the x-intercepts and the vertex. That's a bit lucky. You could do factor form here exactly like this over here, but I'm going to show you how to do this with vertex form just in case you weren't given the x-intercepts. So let's assume actually this point is not given. And let's do the question assuming that that x-intercept is not given. We only have this information over here. I think that's much more practical and useful for you to understand. So if we're given the vertex and not both of the x-intercepts, we want to start with vertex form, which is y equals to a x minus h squared plus k. We want to start by replacing the h and k with our vertex. So y equals to a x minus 1 squared minus 6. Then we want to figure out our a value by subbing in the other point, which is 5 and 0. So y is 0 and x is 5. And then we want to solve this. So I'm going to start with this. So 5 minus 1 is 4. 4 squared is 16. I'll continue up over here. I'm going to move the 6 to the other side. So 6 equals to 16a. Divide by 16 on both sides. 3 over 8 equals a. So our equation is y equals 3 over 8 x minus 1 squared minus 6. I just replaced my a back with 3 over 8. But now we need to convert this to standard form. So the first thing we want to do is write out our bracket twice. Then we want to FOIL out our bracket. X squared minus x plus 1 minus 6. And then combine like terms inside the bracket. So we have x squared minus 2x plus 1 minus 6. Then we want to multiply the 3 over 8 into the bracket. So that's going to be 3 over 8x squared minus 3 over 4x plus 3 over 8 minus 6. And last step is we want to combine these two like terms. So 3 over 8x squared minus 3 over 4x. And then I'll do this in my calculator. 3 over 8 minus 6 is just negative 45 over 8. If you don't have a calculator, you just have to do a common denominator. Okay, so that covers finding equations from graphs. So we can go to our next topic, and almost the final topic, kind of is the final topic. And that's going to be the quadratic formula. Okay, so quadratic formula, I'll write it down for you over here. But quadratic formula is just x equals negative b plus or minus root of b squared minus 4ac divided by 2a. And in a quadratic equation, this is just a, b, and c. Okay, so let's try an example. Let's say we have y 3x squared plus 14x plus 5 equals to 0. We want to solve this quadratic equation over here. You know, a is 3, b is 14, c is 5. So I'm just going to sub it into that equation. X equals negative 14 plus or minus root of 14 squared minus 4 times 3 times 5 divided by 2 times 3. Then we want to do this in 2 steps. Negative 14 plus or minus, and then bottom is 6. And I'll put that whole thing in my calculator. 14 squared minus 4 times 3 times 5 is just 136. And now I'm going to type this whole equation, but I'm just going to do a plus here, not a plus or minus, because it's technically impossible to put plus and minus at the same time. So I'm going to put this in my calculator. And I get negative 0.39 if I round to 2 decimal places. Then I'll switch the plus over here to a minus to get my second solution. So my second solution is just negative 4.27. So why do we have the quadratic formula? Well, what is it even used for? Quadratic formula, as we see, is used to find the x-intercepts. But factoring is also used to find the x-intercepts. So why do we have the quadratic formula and factoring? Well, the truth is, if you see this question in a test, I'm going to rewrite it over here. You're going to try and factor this with man. Complex trinomial, m is 15, a is 14. Two numbers that multiply to 15 and add to 14 does not exist. So if your man method does not work for a trinomial, you do quadratic formula. And if quadratic formula doesn't work, then that just means there's no x-intercepts. Because if x-intercepts exist, then the quadratic formula will 100% work for every question. Okay, when we get our x-intercepts over here, negative 0.39 and negative 4.27, it's a positive equation, so it opens up. And then we can find the vertex using the same midpoint method. So I'm just going to add these and divide by 2. It's 2.33, and to find the y value, I'm going to sub in 2.33 back into the original equation. I get approximately 53.91 if I round 2 decimal places. So as you can see, same process here with the quadratic formula. We just use the quadratic formula to if factoring does not work. But that's pretty much it. see another one. Let's say I have y equals negative x squared minus 3x minus 3. Well, I can actually common factor out a negative, x squared plus 3x plus 3, and then I can do man on the inside. It's a simple trinomial now, so 3, 3. There's no two numbers that multiply to 3 and add to 3. So let's say I want to find my x-intercepts. I'm going to do quadratic formula here. Negative 3 plus or minus root of 3 squared minus 4 times 1 times 3 divided by 2 times 1. That negative out there does not matter. This is negative 3 plus or minus root of 9 minus 12 is negative 3. And then we cannot square root a negative number, which means there are no x-intercepts. So if there are no x-intercepts, does that mean we cannot sketch this graph? Well, we actually can. I'm gonna rewrite it over here. If you have no x-intercepts, we can only sketch the graph based on the y-intercept and finding the vertex. And here's where the method of completing the square comes in. Because if you have no x-intercept, the only way to find the vertex, well, not the only way, you could obviously just use like a quick formula, x equals negative b over 2a as well. But the other way to find the vertex is do completing the square. I want to do completing the square over here, negative x squared plus 3x minus 3 by my magic number. So that's 3 divided by 2 squared, which is 9 over 4. So equals negative x squared plus 3x plus 9 over 4 minus 9 over 4 minus 3, which is negative x squared plus 3x plus 9 over 4. And move this out and multiply with negative 1, so plus 9 over 4 minus 3. Then I'm going to perfect square this bracket, so that's just x plus 3 over 2 squared, and this I'll do in my calculator. 9 over 4 minus 3 is negative 3 over 4. I know that my vertex is a max. X value is negative 3 over 2, and the y value is negative 3 over 4. Know that the y-intercept is negative 3, so if I sketch this out, negative 3 over 2, negative 3 over 4, somewhere approximately here, opens downwards. Oops, I drew that wrong. Because it can't have any x-intercepts. I also put in the wrong place. Negative 3 over 2, negative 3 over 4 is down here. Then, oops. Well, I flattened it a bit, as you can tell. Negative 3 over 2, negative 3 over 4, because I didn't have space. This is my y-intercept, negative 3. Okay, so that pretty much covers this chapter. One last few small things I want to mention is your axis of symmetry is just the x value of your vertex always. I know I didn't do it in any of the previous questions, but for your axis of symmetry, it's just negative 3 over 2 here. And that pretty much covers almost everything in this chapter, just not minor details here or there, but pretty much sketching your quadratics, finding the vertex, finding the x-intercepts, finding the y-intercept, and then doing the sketch. And that's pretty much it in this chapter.